Alright, so the last video talked about simplifying just regular old fractions. Now we're going to look at simplifying algebraic fractions. Gotta be honest, these are kind of fun, so I understand if you kind of do like these a little bit. And I'm being honest, these are kind of fun. Alright, so what we're going to do is we're going to do this in steps. That makes it a little bit easier. First, looking at the numbers. 4 over 6. Can we reduce a 4 over 6? So with the coefficients out front, you just reduce them like a regular fraction. So you can divide them both by 2 to reduce that. 4 divided by 2 is 2. 6 divided by 2 is 3. Alright, now we're going to move on to the x's. I'm just going to rewrite this down here. X squared, you have x times x over an x on the bottom. So when you are dividing with these x's, you can cross them off. 1 for 1. So 1x on the top will cancel out 1x on the bottom. And you have an x left over. And you just have to pay attention to, is that on the top or is that on the bottom? It is on the top, so that's going to go right up there with the 2. Made my fraction bar a little bit long. So our final answer is 2x over 3. Alright, so moving on. 12 x cubed y over 8x y to the fifth. First look at 12 over 8. How can we reduce a 12 over 8? Well, let's divide them both by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Alright, so now you have your x's. X cubed over x. So if you have 3 x's on the top, 1 x on the bottom, sometimes I like to do this in my head, but here's what it looks like visually. 1x is going to cancel out 1x, leaving you with 2 x's on the top. So I'm going to go ahead and put an x squared up there on the top. Alright, now your y's, you have y on the top over, now we've got 5 of them down here. You see how we have more x's on the bottom? It means in the end, we're going to have more x's on the bottom. This one y crosses off that one y, leaving us with 1, 2, 3, 4 y's on the bottom. So we're going to put y to the 4th down there. And that one's done. See, I told you they were kind of fun. Alright, so 16 over 4. 16 and 4, you can divide them both by 4. 16 divided by 4 is 4. Over 4 divided by 4 is 1. Now look at the m's. M to the 4th over m to the 1st. Another thing you could do is, you know that this 1m is going to cancel out one of those. Well, if you had 4 of them and one of them gets canceled away, that leaves you with 3 of them. So m to the 3rd power. Looking at the n's, you have n to the 3rd over n to the 1st. Again, this 1n is going to cancel out one of those 3, leaving you with 2. So you have an n squared. So that's kind of how I do that in my head. But it's this idea where we write it all out. You definitely can do this as much as you want to. It's a very visual way to see what's happening, and you'll get the same answers. Alright, moving on. 3 and 6 have a common factor of 3, so let's divide 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So you have a 1 over a 2. Now your m's, you have m over m squared. So this 1m is going to cancel out one of those. Again, writing it out, it looks like this. So this 1m cancels out one of those, and you can see we're left with an m on the bottom. Now your n's, you have n to the 5th over n squared. Well, if these two n's cancel out 2 of those 5, how many n's do you have left? And you have 3 of them left, and they are left up there on the top. Alright, last one. These do go kind of fast too, which is nice. We have 14 over 21. You can divide those both by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Now, x over x cancels, y over y cancels, so this one actually is just a 2 over 3 for the final answer. So sometimes your variables cancel out completely. Yeah, those are algebraic fractions. Kind of fun.